monitoring of the water cycle in 6 characteristic steps. Step 1. Monitoring of the rivers and lakes. Monitoring of river basins requires to follow hydrometeorological parameters as rainfall, characteristics of the snow cover, flow, and levels in the river beds. The main characteristics are organic pollution, TOC, or COD, oil in water, toxicity, and dissolved oxygen. Step 2. Water intake for drinking water. The water intake should be monitored for algae, bacteriological activity, hydrocarbons, phosphates, nitrates, and turbidity. Step 3. Drinking water treatment process. The drinking water treatment process is controlled by the following analytic solutions: TOC, color, and turbidity of the intake water, optimization of the coagulant dosing, turbidity and particle counters for the filter control, dosing of disinfectant, iron or aluminium monitoring before entering the grid. Step 4. Drinking water distribution. For the drinking water distribution is important to monitor water losses. It is not uncommon if water losses represent as much as 50%. Monitoring of the water losses allow to use available resources on an optimal way. Detection of a growing leakage allows to provide a timely quick maintenance and avoid severe accidents. Spectrometric probes allow instant detection of toxic agents permeating the water network. This can be consequence of industrial accidents or terrorist attacks. Drinking water safety and drinking security is imperative to protect human health and lives. If water is not regularly moved in the grid, consequence is a grid degradation. Inline probes monitoring of main water parameters, including toxics and disinfectants, are the best tool to ensure consistent quality. Step 5. Wastewater collectors. The wastewater sewers need to be monitored for flow. This allows proper configuration to avoid overflow in case of heavy rains. Because of the difficult conditions, best is to use equipment with no contact to the water. Important is to monitor toxicity of the sewer water by means resistance to contamination. Reason is to avoid poisoning of biologic wastewater treatment stages. Step 6. Wastewater treatment, discharge into recipients. For optimization of wastewater treatment plant operation, following monitoring is needed: COD, BOD, ammonium, phosphate, turbidity monitoring on inlet to control chemical treatment, TOC, NH4, and DO, monitoring in the nitrification and denitrification stages, sludge level and density monitoring in the pools, aeration control to optimize airflows, biogas monitoring in the anaerobic treatment, final monitoring and sampling of the cleaned water entering the recipient. Monitoring of the entire cycle, from taking and treatment to cleaning of wastewater and return to recipient, allow consistent use of water, the most valuable liquid of our civilization. Need more info? Contact us.